Hey, it looks like it is time for the triangle angle bisector theorem. That's almost a tongue twister, the triangle angle. So what happens if we bisect one of the angles in a triangle? Well, I'm glad you asked. If we bisect one of the three angles, that ray will divide the opposite side into segments. And those segments will have lengths that are proportional to the lengths of the other two sides. So notice that the length of AD will compare to the length of DB the same way the length of CA compares to the length of CB. Now, of course, when I'm naming similar triangles, I want the order to be in the right order. But remember, if we're just looking at the length of a segment, order does not matter. If you want to put AD, you can put AD. If you'd rather put DA, you can put DA. However, I have to make sure that I compare the correct sides. So if AD is going to be my numerator, and I put DB in my denominator, I then have to make sure CA is in my numerator and CB is in my denominator. Oh, goody, 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 even more algebra. Look at this. We're trying to figure out the length of segment RS, which of course is just X. But I got a problem when I set this up. I want to substitute some values in, and for PQ, that's obviously just going to be 7. For PS, it's obviously going to be 13. For RS, I'll obviously put in an X. But what am I going to put for RQ? RQ doesn't have a label. Every other part either had a variable such as X or a number. Now, for those of you thinking, hey, well, why don't we just call that distance Y? That would create a problem. I only have one equation. I do not want a second variable. If I only have one equation and I want to solve it, I cannot have more than one variable. Well, I know the distance from R to Q plus the distance from R to S has to equal the distance from Q to S. I know RS is X. I know QS is 15. So what is RQ? Well, if I subtract X from each side, RQ is 15 minus X. I can now substitute all those values into my proportion, and notice the only variable in that equation is X. Cross multiply. So I can do X times 7, that has to be on one side of the equation. 15 minus X times 13 has got to be on the other side. Doesn't matter which one is on which side. Also notice that even though I just said it was 15 minus X times 13, notice I put the 13 out in front, and I use parentheses to remind myself that the entire quantity 15 minus X has to be multiplied by 13. 13 times 15, probably want to grab a calculator for that one. That's 195. 13 times X, of course, is 13X. Okay, I want my X's on one side of the variable and my numbers on the other. It looks like the quickest, easiest way here would be to add 13X to each side. I often try to get my variable on the left-hand side of the equation, but here it was just quicker to move it to the right-hand side. Divide both sides by 20, and again, your best friend in the whole wide world might be a calculator. 9.75 would be the value of X. So the length of segment RS is 9.75. Again, another real short PowerPoint. The vast majority of what we're doing is much akin to what we did with congruence. Similarities, just put a little extra twist on it. We've been working with proportions this whole unit. Just throwing in a little bit more algebra now.